Hi, we're team number 3, and we're going to present what is the equivalent resistance of the arrangement in the figure.
Then the current through each resistor when the circuit is connected to a 12 volts battery. So first we have this circuit that has 8 resistors. We have to simplify it until one resistor so we can know the equivalent resistance. So first we simplify these 3 resistors into only one. To do that, we summarize the inverse of these 3 numbers and we get 1 ohm. Later on, we simplify these 2 resistors into one, doing the same process because they are in parallel. So we got that the new voltage is 2.67 ohms. For the next step, we have to simplify these 2 and these 2 because they are in circuit. We just summarize them and we get these new 2 resistors. For the almost final step, we simplify these 2 resistors that are in parallel into only one resistor, summarizing the inverse of the 2 numbers. Then, because these 2 are in circuit, we simplify them by just adding it, and we get that the equivalent resistance is 8.07 ohms. And later, we have to get the current through each resistor when the circuit is connected to a 12 volts battery. So in this case, we know that the voltage is 12 volts. And to get the current, we have to use this formula. And we divide V over R. And we get that the current is 1.59 amperes. Later on, because these 2 connectors are in series, we know that they have the same current, but we have to get the new voltage, and we use the same formula, and we just multiply I times R, and we get these results. Later, we simplify this, we separate these 2, and because they are in parallel, they have the same voltage. We know the resistance, so we divide the voltage over the resistance, and we get the current. Up in here, we separate these 2 and these 2, and they are in series, so we know that they have the same current, and we get the new voltage using the same formula before mentioned. Then, for these ones, we separate this one, and because they are in parallel, they have the same voltage, as you can see, and we get the current by dividing V over R. And finally, we separate these 3 connectors, and they are in parallel, so they have the same voltage, and we know the new currents. So finally we can write, and the resistance 8, because it didn't change from here, it has a current of 1.5 amperes. Finally, as a conclusion, we can say that the first resistor has a current of 0.48 amperes, the second one has a 0.16 amperes current, the third one has a 0.32 amperes, the fourth one has a 1.02 amperes, the fifth one has 0.70 amperes, the next